Hey, thanks for tuning into my YouTube channel. This is the CNC dude saying hi once again with a very exciting project for today. Last time on my last video, I was mostly working with the CNC milling machine, but in like manual mode, what I call manual mode, right? We were using the jogging wheel or pendant, if you will, and we were typing G codes and the machine was moving around, but it wasn't really like a program where you have a bunch of lines going up and down with a bunch of different G codes for doing arcs and pockets, and it wasn't something like that. It was basically manual machining stuff that you could do with your hand dials if you had a manual milling machine with a DRO. So we were taking advantage of Max 3 DRO for doing that. And in that sense, although I think that a CNC milling machine is way better than a manual milling machine, but in that sense, if you're only gonna like face stuff or maybe use a fly cutter to clean up the top, maybe make a few holes, that is stuff that you can do easily with a manual milling machine. So you really do not need a CNC milling machine to make any of that happen. But there are certain projects, very intricate projects, fairly complex, where a milling machine stops being the right tool. I'm not saying it's impossible. I'm certain there are certain gurus out there, maybe 60 or 70 years ago when there were no CNC machines, they would take a manual milling machine and make miracles, right? I am not a miracle worker when it comes to machining, so I actually have to cheat and use CNC machining, and especially for those super intricate projects. And today I have an idea which will illustrate what I'm talking about. I'm going to take advantage of today's date. Today is February 3rd, 2014, which means that in less than 2 weeks, basically in a week and a half, it's going to be St. Valentine's Day. This is February, the month of love, of friendship. So we're going to take advantage of that and make something that is pretty hard to make with a manual milling machine, but super duper easy for a CNC milling machine. And that will be, what else could it be other than a heart, right? Lots of curves, lots of intricate details. We can take advantage of CNC machining to make it happen. Super impossible for me to make it by hand, I can tell you that. Now, the inspiration comes from a few weeks ago. I was with my wife at the local Barnes & Nobles. Not that I work for Barnes & Nobles or that I'm trying to get paid by Barnes & Nobles. I mean, basically it's the only library left where you can actually buy the monthly or bi-monthly Machinist magazine. So I was there, I was about to pay, and I see this lovely heart. Let me put a picture in the screen so you can see what I'm talking about. Very, very beautiful, lots of curvy shapes, and very well made piece of art. And I'm thinking, instead of thinking, oh, let me buy this, I'm thinking, let's make it. Let's make a heart in the CNC machine. What an awesome gift, what an awesome present if we make it instead of just buy it. And then, it's like I have this multi-$1,000 piece of equipment. Let's make something that is worth $10 so that I can actually pay for it like in a million years. But the trick, I'm going to be honest with you, I'm not an artist, so don't expect that I'm going to be able to make a heart as beautiful as one on the picture. That's for certain. I'm not that good I'm not an artist at all. When it comes to art, I suck more than a chop vacuum cleaner. But it's gonna look like a heart. So I think this is an excellent example of a project that would require, so much hard work to achieve on a manual milling machine. But on a CNC milling machine, it's gonna be a piece of cake. And this is also, I'm going to take advantage of this project to show you the different steps. I'm going to go from conception to actual construction. I'm going to take what is on my head, I'm going to take it to the computer, we're going to draw it in the computer, no need to do it on paper, everything's going to be on the computer. Then we're going to, create a model. Then we're going to generate the instructions, or not, the processes required to get the part built, and then we'll get the instructions, which we'll load into the machine, and we will see the machine making it happen. Pretty impressive, the process, and you'll get an idea of what it takes to elaborate a concept in your mind excuse me, and make it happen in real life on a CNC milling machine. So without further ado, let's get it going. You know, most projects start with a search engine. My favorite search engine is Google. So I'm gonna type heart, and of course the first thing that is gonna come up is the band. Pretty cool band, by the way, but not what I'm looking for. I'm looking for an actual picture of a heart. Now it may be obvious that I'm kind of stealing a heart here, so hopefully that's not too much of a crime. And actually, I promise that I'm not gonna use this heart as you would imagine as being steel. I think this one will do. So I'm just gonna do copy, and I'm gonna go to CorelDRAW. Now, CorelDRAW is not a tool that you would use as a CAD for 3D projects. Actually, it's a pretty good tool for 2D drawing and doing stuff like clip arts and also all sorts of artwork. The place where I have used CorelDRAW the most is for my laser engraving projects, and then of course because I had to learn it, I have decided to use it for my CNC plasma cutter as well, because it's very easy to do those pretty convoluted 2D figures. Now all we're gonna do here is trace bitmap. Quick trace will do. I really don't care much about details and stuff like that. This is not trying to do. I mean, if it wasn't for an actual engraving project, I may get deeper, but this will do. I can get rid of the bitmap now, so let's just do delete. I'm going to ungroup this guy. I don't need the white space, and actually I don't even need the red, so I'm gonna get rid of it. But that's what I need. That's our heart. Now I have to set the size of the heart in here, or otherwise I imagine you can do it in Inventor as well, but I'm not certain I know how to. So I'm just gonna say this is 3 inches. This is the 3 inches in wide, as you can see here, and then the vertical follows along because I have it locked. So it is preserving the ratio. It's locking the ratio of the figure. If this had not been locked, then I would have changed this to 3, and this would have remained whatever it was, and it would have looked squash, I guess. Okay, so these are hard. Now I'm going to export it as a DXF, and I am going to import it in Inventor. Here I am in Inventor, and now we can start creating a 3D model. So I'm going to do a new standard part, and this is basically what is known as the sketch. I really haven't used any other tool other than Inventor for 3D modeling, so I don't know much about SolidWorks or RhinoCAD or any of the other tools. So I'm not certain how different or similar this is. But anyway, what I'm gonna do here is open up the. I'm going to import the AutoCAD. And there it is. Now I'm going to. I want this to be constrained. I'm gonna say it's gonna be here. Here. Oh man, it took everything. Okay, that didn't work. I know what I need to do. Okay, so I'm gonna finish the sketch to show you a problem. The idea here is to extrude this into a solid, but really I can't, because for some reason when this vector was imported from the DXF file, it came up as an open. It's not a closed surface, I guess. So I gotta go back to sketch, and I have to say sketch doctor. Okay, I'm gonna diagnose it. Just check for everything. It's gonna find a bunch of missing items, so you're just gonna do next, finish, and now this is where it start asking if I want to add the points, and of course the answer is yes. But this could be hundreds, so all I'm gonna do is I'm gonna press the Y key, and it's just gonna go there until it's done. Okay, I don't think it was hundreds in this case, but I've done it where it is hundreds, and when that happens, boy, it takes a while to actually just be pressing X, 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 and X. Okay, so what I'm trying to do here is I want to move this guy so that this node is here. Really, it's not that important, but I'm kind of picky, so let's just do it. I have to deselect this guy, and now I'm gonna constrain it. This guy here. Man, that didn't work either. I don't think that's gonna work, so I'm just gonna forget about it. Now, if I want to extrude this, now I can. All right, now I'm gonna say 0.25 because most likely that's the kind of aluminum that I'm gonna work with. Quarter of an inch. Now, one thing that I would have wanted to do here, but unfortunately I cannot do, is to create an offset. It doesn't let me. Apparently, the shape is too convoluted, so I cannot create a smaller heart. That would have allowed us to make some fancy figures, but unfortunately it's not possible. I don't know why. I would definitely like to know why I cannot do that, but I guess it's because of the complexity of the shape, because most likely this is a bunch of there are so many vectors in here that I guess it doesn't like it. Let me try something real quick just to see. I don't think that's gonna do it. Yeah, it's. I think it's too complex. Well, here is our part. I'm not gonna do much more here because this is just an example, and I am really not an artist. I don't even know if you can do super duper complex stuff with a bunch of curves here in Inventor. I imagine other tools like Rhino and perhaps I don't know, a Libre or those softwares that are a little bit more artistically inclined than this one. This it is my impression. This is more of an engineering suit, for designing like motors or cars or conveyors, convoluted stuff that really doesn't have to look pretty. Just have to work. Everything have to align and mesh. So I don't think this is the software for designing pretty stuff. Now, the next step is to basically export this. Do not do a save as. A save as is not gonna give you the file format that you need. We need to do an export, and we have to choose IGES, or I don't know if any other format works. I have been using IGES, but maybe other formats work as well. I have saved my file, my IGES file, and now I'm gonna go to Sprue CAM. Sprue CAM is the CAM. It's basically the computer-aided manufacturing. So let me take a pause here to answer a very important CAM question. One of the questions that I see the most out there on blogs and forums is, what is a good CAM software to use? What is a good computer-aided manufacturing piece of software to use on my CNC endeavors? The way that I see this, there is no such thing as a good CAM software. What there is good chemists or individuals capable of extracting the juices out of the CAM software that they have chosen. The reason for me to reach this conclusion is because 3 years ago, before I started tinkering with CNC, I had this notion that the CNC software was magical enough for me to input one model, press one button, and voila, I get this humongous list of G code that will get the part in question manufactured. Today our CAM software will in fact take a model and you will press a button, but in between you'll have to fill a bunch of tasks to get the job done. For example, you're going to have to choose tools, algorithms, advances, speeds, feed rates, lines, curves, processes, and a bunch of parameters that must be selected properly in order for the CAMing process to work correctly. So this software, the software where we just press one button and the machine does everything, the computer does everything, does not exist today. But it will be available in the future. I anticipate this is going to happen like a week before Skynet becomes online. And we'll have T-1000 Terminator units working around with, "I'll come the crap out of you." So in the meantime, however, we're going to have to learn how to do this ourselves. And I can assure you the learning curve is pretty steep. I used to have way much more hair than I have today. But hey, I wish you good luck. You know, I hope you don't find my Terminator impression too infantile. Um, but once you see all of this stuff that we have to do now, you'll see what I mean. I mean, if you think this is gonna be a piece of cake, brace for impact. The only simple stuff here is importing the model. So let me just go ahead and do that. Okay, I have imported the heart. I am not certain if I'm supposed to do this, to do a sewing, a sew operation. I think when you load the part, it is already complete, but I'm doing it anyway. I usually do it anyway, but whether it needs to be done or not, I'm not certain. What I do need to do, however, is find my origin, my 000. And to do, you know, there are sometimes you have to do stuff like rotation, or you may even need to scale the part, or maybe you have to mirror it. Most of the time, the only things that I do is either rotation, if I need to, if you know, if it is standing up and I want it to be laying on the vise, and then locate the 0. And I go for min, max, max, so that my 000 is on the top left, top left. And the reason why I like this origin, most people like the bottom left, because then everything is positive, right? X positive, Y positive. It's kind of odd that I'm choosing top left, because now I have negative Y and positive X. The only reason why I have chosen this origin nomenclature is because this is what I'm accustomed to do on the laser. On the laser, everything, just because of how it's built, everything is positive on X and negative on Y. So I just inherited that, but you know, it's up to you. You can even put it on the center if you want. There is no wrong way here. As long as you follow the origin from your cam into your machine, you'll be fine. So we're done here. Now I am going to start by adding a workpiece, and you know, there is already a workpiece, but this is not going to let us see a lot. So I'm going to go into workpiece, and I'm going to say primitive box, and I'm going to say, I guess I have to do this. That didn't do much. Let me do this 1 and 0. Okay, I think I have to add it and then double click, and now I can change the stock. But I don't want anything on C. I only want it on X and Y. There we go. Now we have a nice piece of aluminum. Do notice that I still, my 0, my origin is here. So in theory, you could move that in here if you wanted, but I know what I'm gonna do, so that's no big deal. The only reason why I added this workpiece is because I wanted to see the operations as they go across the heart shape. And if I don't have this workpiece, it becomes harder to see. But you know, my workpiece is not even gonna be this, which is I guess, well, let's see how big this is. We can do the measurement tool. Well, I imagine this must be a 4x4 or something like that, but that's irrelevant. The first thing that we want to do is to do create a process for, let's see, finishing 2D contouring. 2D contouring, that's the process that is going to basically carve the contour of this shape. Now we can to actually select the shape. Well, look at that, it selected the whole thing. That is amazing. Basically, you just select, double click on one of the lines, and it selects the contour. And then you go here to your job assignment and press curve. And that didn't work because for some reason it is trying to measure. That's intriguing. Let me do remove selected. Okay, let's do this with the shift. Man, why is it measuring? That is the kind of stuff that really bugs me about this software. I don't want to measure, damn it. Okay, let's see if it works now. It doesn't. Well, you know, this pretty much means I'm gonna have to close this and start from scratch because the software is doing something stupid which I cannot understand. So I'm just gonna close it and I'll return when I have returned to this point and we're ready to proceed. All right, I am back, and in theory, I should be able to select this. Man, it keeps on doing the same thing. What am I doing wrong? You know what I think the problem is? I think the problem is this sketch. Let's delete this sketch. I am going to export this again and import it again. So I'll meet you on the export cam once again. Alright guys, I am back. This is the third time I'm trying this, and I actually believe that the fact that I had a sketch on top of this guy that had nothing was messing up the sprue cam. It's kind of preposterous, but I think that was the problem. Let's give this a try. So I'm gonna create my 2D contouring, and now I'm gonna say let's just select this guy, press Control, select this guy, and now work curve, bam, and now it works. Amazing. That truly baffles me. That's something like the lines on top of that meaningless sketch was confusing sprue cam to this level. I mean, wow. Okay, now we have this is basically what the tool is gonna do. So as you can see, this is my mill. It's gonna start here, it's gonna end there, and you know, it's just gonna go all the way. I'm not gonna animate it yet because this is not a tool I want to use. Now we have to select the tool. You would imagine this thing knows what it needs to do, but not really. We have to tell it to. I'm gonna select the end mill. It's gonna be running at 1800 RPM. That may be too fast. So let's go at 10. Let's do. I'm gonna do normal. And the reason why I like to do some approach is because otherwise it's gonna start right at the contour, and you may get a nick where it enters. But if you do a normal retraction, approach and retraction, then you get better response. Here is this is the safe plane. Top level is 0, and I'm not gonna go all the way. I'm gonna go to 22.5 or 225 mils, and I'm gonna leave 20 mils. And I'll explain later why I want to do that. I think 2 passes will be fine. 2 passes. Strategy is okay. Trimming is okay. Transition is okay. Transformation is okay. And toolpath template, that's okay. Bam, that's our cut here. So if I do, if I run it and I do a simulation, we will see that the color is gonna come down and it's going to cut the heart, but notice it's gonna leave a little bit of stuck. Now the reason why I like to do that is because I am basically making a groove in here. So you're doing both, and you know, I'm not an expert. This is my impression, but I may be completely wrong, and I may actually be doing this wrong. So that must be why I'm doing these extra steps. Maybe if I had the right tools or the right speeds and the right feed rates, then it would work better. But if I just try to cut to the line, because the meter is like chattering a lot, I mean, it's trying to cut so much material that the chatter, I mean, the finish is horrendous. It's pretty lousy. So what I'm gonna do is I'm gonna cut deep, far away from the line, and then I am going to cut into the line so that I'm only removing a little bit. So you can call this a roughing and a finishing operation. So again, those have to be done by hand. The computer doesn't know, the system doesn't know that that's going to result in pure finishing, in a poor finish. But I have seen it happen, so now I know. So now I'm basically going to copy and paste this guy, and we're gonna go back to tool. We can do fit speed. I think that this will be fine. This will be fine. Now I'm going to do only 1 pass. I'm still gonna go to 0.225, and I haven't explained why yet. But now I'm going to remove the stock. Okay. Okay, let's see. I have pretty much my heart in here. Now another thing that I want to explain, my tool number 1 for process number 1, and then for my process number 2, I'm still using tool number 1. That means that the guy is going to do the first process and the second process without stopping. Now I have to be careful when I do the next copy and paste, because I want to do a chamfer on this one, you know, just to make it prettier. And for that I'm going to select my spot drill mill, select, and now I'm going to do let's see, height. I want to cut with, let's say 0.1, not too much, 0.625. Yeah, that's this green line, that's what it's gonna use to cut. Okay, now I'm going to, yeah, this is to, I'm gonna use 1800 again. Hopefully that works. I'm gonna do 8. I'm gonna keep the same approaches. Now I have to be cautious here. I don't want to go down that much, so let's say 0.1. And yeah, that works. Let's take a look at how this looks in the meantime. Let me speed this up a little bit. You have already seen this. Cleaning up, and now we're doing the chamfering. The chamfering is not going to show a lot because that's not part of the model, but you'll see that it will cut until here. I think that's good enough. And it's going to throw a warning because obviously it's doing something that it shouldn't. It's basically cutting. I mean, I'm telling it to, but the model doesn't say that you're supposed to do this. So we're going deeper than we were supposed to. We're removing material that we were not supposed to remove. So I don't think the software likes that, unfortunately. Okay, now we have done the great majority. Let me take this back. We have done most of the carving. What we need to do now is release the heart from the block of aluminum. If I do that on a single blow, what's going to happen is that when there is very little amount of aluminum left, the heart is going to start vibrating in place, and you know, most likely it's going to come in contact with the blade and it's going to look ugly. So what I like to do is leave some tabs. So now I'm going to do, actually I'm going to copy this guy, copy, and I'm going to put it down there, paste. Oh, but before I do this, I cannot forget this. I have to name this tool number 2, otherwise it's not gonna change the tool. The program is just gonna go, and now it's gonna be a mess. So I remember to do that. Remember to change the tool number whenever you want to specify a new tool change, basically. Okay, so this guy is gonna be tool number 3, and everything else is okay. But now I'm gonna go all the way. You know, I'm gonna take it a little bit more. It doesn't matter because I mean the depth. Basically, I'm just gonna go all the way. So it really doesn't matter if it's below the. This pretty much ensures that you're gonna go all the way. But what we need to do now is move. See if it lets me grab the. Guess I have to select this guy. There we go. No. It's not letting me grab it. I hate it when that happens. Darn it. Okay. Yet another one of the annoyances of coming. In theory, I'm supposed. There we go. Darn it! Don't even know how I managed that to happen. I know it can be done. How I did it beats me. Okay, now I'm gonna copy this guy again. Copy, paste. But now I'm gonna do the other side. I guess I have to go a little bit in here, and well, I guess I have to do it like this. Oh man, how do I do this? Yep, like this. There we go. Now I don't even remember where these guys were, which means that I don't know how big are the tabs. We're gonna have to run this continuously until we get a tab small enough. Do this very fast. Okay, those are my tabs. So I guess I can make this one smaller. Let me just move that a little bit. Like that. I guess I have to clean that up. Let's do reset, run. Okay, and then of course you would use a saw to segment this and a sander to clean the size up a little bit, or a file. So look at this: 1, 2, 3, 4, 5 processes to do our super simple heart. I mean, if we wanted to make a more complex heart, you can imagine the level of complexity that we will need to put into this puppy here. And of course, inside each one of these processes, we had to specify. Let's take a look. Which tool we wanted to use, the speed, the cut feed. By the way, you can also change the approach feed. If it is going too fast, I usually like to approach at a smaller rate, so we can do that. The lead in and the lead out, and there is like a gazillion parameters that I didn't even touch in here. Parameters, I mean, the machine doesn't know where it can go, so you have to tell it that you want the safe plane to be 100 mils, what is the top level, what is the bottom level, how many cuts you want to do, or the depth of cut. If you want the stock, you have to specify that. The strategy, I didn't touch it because pretty much everything in here it works for me, but look at this. How many tabs do we have in here? Trimming, transition, transformation, and if you want to add auxiliary commands or stuff, I mean, this can get very complex, very complex. And that's only the 2D contouring, but you know, there are holes, there is water line, drive, plane, hole machining, pocketing in. Look at this. I mean, this is truly, this is not piece of cake. It took me months to be able to make something, and even today I have to come back to the camming process continuously, just because I don't do this enough, and I forget what are the right parameters, so I have to retry them again. And I think making these videos is it's great for me, because three months down the road I'll have to make something similar, and I'll be like, man, what did work for me? And most likely it's gonna be on this video, so I'll be able to just watch the video again and say, oh well, I'm just gonna copy these parameters, and that's what I'm gonna use. So this is half of the process. We basically draw the heart. We were able to get the model, get the camming. Now we have to go into the machine, but I think this has been long enough, so I'll do that in a separate video. So this is Jose Quiñones, the CNC dude. Until the next time, have a good one.